Oh, hey guys, what's up? Eddie Aho here with KissAnalog.com. Hey, we're back here at the lab. The IEMA stuff, the setup. This time it's resistors. We did cables, right? I showed it audio frequencies. Cables are flat. Okay? This would be kind of like your interconnect cables. You know what I'm doing, interconnecting things, sending signals around, low power signals, right? Okay, so we're not talking speaker cables. We'll get into that another time, but it's giving you an idea, right? How things work, frequencies. All right, guys, what about resistors? So we use the resistors as loads for our amplifier. You know, 4 ohm, 8 ohms, kind of common. Similar to what a loudspeaker would do. But the loudspeakers, we all know, they have crossovers. There's different things going on. It's just that when they're rated at 4 ohms or 8 ohms, they're probably, I don't know, I've heard that a lot of 8 ohm speakers probably really test around 6 ohms, but they change over frequency bands. But when we're testing an amplifier, we're testing one component, just like I did when I tested cables. I'm testing the cable. If the cable has no impedance, no changes, then it doesn't matter what system it's in. It's not going to have any reactance. Impedance is reactance, right? It's another way of saying, impedance is that you get inductive reactance, capacitive reactance, resistance. All those things together make up Z, impedance. Okay, so our X of L's, inductors, X of C's, capacitors, or our R's, resistance, they're all combined. So with resistance we have reactances, inductance, capacitance, and that gives us impedance. Well, if those inductances and capacitance are small in comparison to the frequency, if there's no change, if they have no impact, then they're essentially transparent. It doesn't matter if you're in a resolving system or in a crappy system, the cable's just doing its thing. And that's why I showed some inexpensive cables and all that kind of stuff. The only thing I've really noticed, guys, is the connectors themselves. If you place them in, don't touch them, they're fine. Some connectors, you can wiggle them around and stuff. They're great. Other connectors, yeah, you move them around and they jump around. But the cables themselves are fine. And the connectors, it doesn't cost that much more to get a cable with a connector that's good versus one that has a weaker spring. So these BNC connectors are kind of, a little bit more complex than the stuff we use in audio. Anyway, so they have a small pin in them, then the thing around the outside. Guys, what I'm going to do is I'm going to test some inductors, and we're going to see how much of that reactance they have, or how much of it, is it R, resistance across the audio band, or is it Z? Is it a combination of capacitance, reactance, inductive reactance, and all those things that make up Z, impedance? So is impedance basically R with no reactance? Yeah, that's what we kind of showed in the cable. Now we want to see on the resistor, because when we're testing the amplifier, we want to think, okay, we're not adding another variable, the resistor that's changing like the speaker would. We'll test, we'll test the output of the amplifier for that kind of change later. But for Bode plots, distortions and all that kind of stuff, we don't want all that stuff happening. We want to fix all the variables so nothing else is changing. So if we know that our cables are flat, which they are, and we know, our preamp is good, and we know our amplifier is good, we know how they react, then when we put them together, we should have a good idea of what's going to happen, right? There's no surprises. It's not like we just go, gosh, these things are always, they react differently with each other. Why? We don't know. We just mix them up until we have something that sounds good. Oh, hey, throw a $20,000 cable in there. That'll fix it. Kind of punches. All right, guys, let's do it. We're going to test. Now here, what I'm going to do is I have some resistors. We have some 1 ohm resistors, and these are like 2 watt guys. These are actually used in some of these amplifier kits I'm putting together. So we want to make sure, we're worried about cables and all this stuff, but what about the bloody components on the board, right? Oh, let's use gold or silver or oxygen-free copper, all this ridiculous stuff, when there's actual things that make a difference, like the signal going through a resistor, on your amplifier, your transistors. So I want to check these just see if they're good, but it'll also give us 1 ohm will give us some resolution to show what kind of resolution we have at 1 ohm to know what we'll have at 4 ohm or 8 ohm as far as our setup goes. Okay, so I'm going to start off with the 1 ohm, and here let me get that going. Alright guys, so here's my screen. Now first of all, let me go backwards just for a moment, just to show you. I'm with the Omicron Labs Boldy 100 device, right? We love this thing, it's great, does many things, and what we want to do in this case, I could do this 1 port. I was going to test it this way, which is quick and simple. Low frequencies, totally fine to do, audio frequencies, but to take out some of the variables, because to take out the cable, if I do it this way, this shunt through, then I have a cable here, and the cables kind of zero each other out. So we're just measuring across this, okay? So let's just do that, because, okay, if I go back to this method up here, I have those micro clips, right? And then they come off, so they're part of my DUT at this point. They're part of this stuff out here. If I come down here, the micro clips actually cancel each other, because the ones on this side kind of cancel the ones on this side. So it's like one's the output voltage that's putting the signal, the other one's the picking up the signal. And so yeah, it's kind of interesting. They kind of cancel here. So let me go back, because I've got some things set up. I don't want to just select that. I normally select that, take me to this screen. Now look, let me go to this thing. Let me show you the source on the left, okay? And I've changed the signal up and down. I haven't really, I don't notice the difference, guys. I put real small signals and bigger signals just to see if it made a difference. It comes in here. The source has 50 ohms to the output, to this guy. And then receiver 1 is taking the voltage here, okay? So, and then receiver 2 is taking the voltage on the other end of this cable. So otherwise it would be across, like say this 50 ohm, but now the 50 ohm is stretched across this cable over here, and then we have a 50 ohm to ground here. So we still have our 50 ohm impedance on this side, 50 ohm impedance on that side, so it's kind of balanced. Well, it's not kind of, it is. And that way we get a nice clean measurement. So, okay, there we are. It's been running. Whoops, I turned it off. Get it running again. So you see the arrows kind of coming across the screen right here. And there we go. I was going to say if it's too slow, I'm going to fast forward to this stuff, because some of these measurements are kind of slow. Magnitude over here, and then I have log on the y-axis. You know what, guys? I'm going to turn it to linear. Since we're looking at just magnitude ohms, I think we're just looking at ohms instead of decibels. I think that's easier for a lot of people, right? So let's just do it that way. So this blue thing in the middle is the phase, and that's over here. So the phase is just 0. It's flat, and then it goes up to 50 degrees and back down. And it doesn't even change until we get out to between 10 and 100K. 100K, it's barely lifting up. It's like 10 degrees right here. It hits 10 degrees at 20, 30, 40, 50, about 50K. Okay? So I got to get zoomed down on the ohms, because it's so far down there we can't see it right now. There we go. There's the ohms. Wondering where the heck's the ohms. So, okay, we're 1 ohm, like I said, we're going to be. No, we'll go, whoops. Okay, so 2 ohms right in the middle, so 0 to 2 ohms. So, you know what? I'm going to go 1.4 ohms, I think. Let me see if that'll work. Okay, and then on this one, I'm going to put 0.8 ohms, I think, 0.8, okay? All right, so we're at 0.8 to 1.4, so we got 0.6 ohms across here. Almost a half, 0.6 ohms from top to bottom. I just did even numbers, just so whatever. So it looks like it's read as 1.02. So man, it is pretty darn close to 1 ohm. Here's 1 ohm, 102. Look at that, guys. And then all the way out to 100K, we're still just hovering right around 1 ohm. I mean, that's an awesome resistor. And then out here at 2, 3, 4, 500 kilohertz, we're at 1.04 ohms. So it's gone up 0.02 ohms. And then it takes off, it goes off the screen at 1.5 ohms. So yeah, it goes off because it's going inductive, right? And so then our phase is right here. Then we go to 1K, I can't remember where that went off the screen. Whoops. Then we go to 100 ohms. I'll go to 10 ohms, I can't remember where that came off the screen. Okay, so it goes up to 8 ohms. So it's way down here and goes up to 8 ohms and then starts going a little capacitive out here at 20, 30 megahertz. So we're going from 10 hertz, 40 meg. You see over here on the left top corner? Alright guys, that is a pretty darn flat resistor. Oh shoot, I'm going to have to go back to 1.4. There's something I wanted to do. You guys may have noticed, hopefully I don't mess up the connections here. I spread, see how I spread these to the tips? I just wanted to see if it made any difference. Oh, you know what, to make it easier for us to see, I'm going to save that one, that green measurement, okay? I'm going to slide these probes over right to the body of the resistor. We'll see. At these frequencies, may not make a difference, but sometimes it might because the leads are part of the inductance. Yeah, it does. Look at that, guys. Wow, it's interesting what it does. So it takes away some of the inductance because now the leads are shorter. Wow, that's interesting, right? Now, those are 0.02 ohm. This is just right above 1 ohm, between 1 ohm and 1.02, like 20 milliohm. So it's not even, man, guys, it changes like, wow, just really small ohms all the way out here to almost 1 meg now. So it goes out further. Look at that. Look how much we extended it just by taking the leads, you know, off the thing. So that's interesting, right? That's something. See, you learned something, hopefully. Give me a thumbs up. Really appreciate it when you like the video. It makes a difference, guys. Subscribe if you haven't too. Guys, free way to support the channel. Just hit the like button down below. If you thought that was cool, help me out. All right? Thank you. Appreciate it. Okay, you know what? I'm going to go ahead and save this measurement. Pretty soon we'll forget which ones are which. Okay, I'm going to stick another 1 ohm in here. I'm just curious. Now, guys, these 1 ohm resistors, like I said, I use them in amplifier builds. And I think this red one's a KOA resistor. And so I pulled this one out because I was running out of the blue ones on one kit that I built. And so I used that. And I was like, oh, I hope that one works. Now, I tried to twist these things together and one of them was untwisted. So I tried to twist the leads, even though this test kind of cancels them. It does a pretty good job. I still try to make my measurements as clean as possible. So close to the body. So it does look a little bit better when both of these are twisted. I think it just takes away some inductance from the measurement. And yeah, so there we go. So guys, those 1 ohm resistors look pretty good, right? I'll save this one. We'll just add up some of these 1 ohm resistors, okay? Now, you know what? I can turn off the phase. So we just see there, I've turned it back on just so you can look at it real quick in case you weren't looking. They're all 0 phase until the inductance kicks in. Then they want to go 90 degrees with the phase shift, you know. But they don't quite get there because there's some capacitance inside this guy. The windings being close to each other probably. Then, you know, 10 megahertz or, I don't know, what is that, 6 megahertz? They start to go capacitive and they drop back down. Maybe I'll just leave them since they're grouped pretty tight. It's not messing up the screen too much, right? So I'm going to leave them. So let's get another, I think I have one more 1 ohm resistor. I just, by luck, uh-oh, I almost lost that one. By luck, I just happened to find some 1 ohm resistors of different kinds. So I thought, oh, that'd be interesting. So this looks like a wire wound, but it says, I think it says non-inductive on it. So it's a RS5, or it's a Dell resistor, which some of you old timers know Dell resistors. Really good resistors. Okay, it's right down there at 1 ohm. I mean, man, guys. And I think this is 0.05%, this one. I don't know what you guys think, but if I'm doing tests, whatever out to 100K, I don't have to worry about my resistors doing some weird stuff. It looks like they're pretty good. So I feel like these resistors are awesome for audio. Alright guys, so let's go ahead. Oh, you know what? I have this reference, this 10 ohm. It's a little bit more than our 8 ohms, so now we're going a little bit on the bigger side. But you know, it's a reference resistor. I was just really curious. It's like 0.05%. So I don't know how they made it. I'm just curious if they made it non-inductive since it's a reference resistor. It was made by Genrad. They were like big in RF and radio stuff. Genrad, it was called General Radio Company, but a lot of us guys just call them Genrad, and they're like, you know, very well respected in the field. Concord, Massachusetts is where they're from. So anyway, so let's go ahead. Well, it's already, well, it's showing us the phase. See the phase? I got to go up to 10 ohms, but look at the phase while we're here. We can focus in on that. Look at the phase. It's less than those other, the 1 ohm. So this is 10 ohms. And you know what? If it has the same inductance with more ohms, it would have less impact on the resistance, right? That's why I started off the 1 ohm, just so we could kind of get some good resolution on our readings here. Okay, there's our red, 10 ohms right there, right across the middle of the screen. Man, it's pretty darn flat out past a megahertz. That, you guys, that's impressive, right? Here, let's zero in on that. I'll go 11 ohms, and we'll go 9 ohms here. We got from 9 to 11 ohms. Look at there we go. It's below 10.1 ohms. So, wow, that's crazy. And then it drops right down to 10 ohms, and then goes down to 9.95 ohms, probably out to 1 meg. That is nuts. And then it goes very inductive. Man, impressive, right? Okay, non-inductive. There's a couple guys that came up with a way to wind a resistor, and this one, you can see the picture. I'll show you a close-up picture right here, maybe. Let's say that this piece of, you start off with a piece of ceramic, a tube, and you got to put 20 turns on it to get the ohms you want. So you go 10 turns this way, 10 turns back the other way. We wrap them so they overlap each other, and you'll see the crosses in this. And the inductance going one way cancels the inductance going the other way, so it ends up being non-inductive. It's really neat. Okay, that's these reference resistors. We're going to get rid of them. Anyway, so you know what? I've got different resistors, but let's just jump on to this guy right here. I think he's an 8 ohm. Okay. All right, guys. So here's our 8 ohm load. And so I got to drop this down to 8 ohms so we can see it even. So I go to 7. Now I'll go to 10 on this guy, I guess. So we're zooming right in on that. So it's about 8.5 ohms, it looks like. Whoops. I got it on the 4 ohm resistor. There we go. Sorry, I thought that was the 8 ohm down there. Okay, so let's go down to 3 ohms. And I'll drop this guy down. We'll zoom in on him. So that's 3 ohms across the whole screen. I can zoom in a little tighter. I can hear you guys saying tighter. So we'll go from 5 ohms to 2 ohm. Okay, so 2 ohm down here, 5 ohm up here. And the red one, this trace one up here, impedance magnitude, it's just coming across. Look at that. 4.1 ohm, and then right out here at 2, 3, 4, 5, 6, 7K, it starts to go up. And what is it? 20K, it's all the way up to 4.6. So it's changed to half an ohm as it's starting to go inductive. So I'd say at 10K we're good. At 20K, it's starting to go inductive. Now let's go up higher to see how high it goes inductive. Okay, at 100K, we're up to about 9 ohms, so it's doubled. But look, it goes pretty high up there. It peaks up here at 2, 3, 4, 4.5 megahertz, something like that. It peaks up to 150 ohms. So, yeah. So out there, high frequency, this guy, and look, we've got some, even though I got these things twisted, they are kind of long. So come on, you're not going to do that when you're doing things at megahertz, okay? We're talking audio. Audio is ridiculously slow, okay? It's, yeah. A lot of the high frequency parasitic just barely start to come into play. So at 10 or 20K, some of the frequency stuff starts to take effect a little bit, you can see. And that's because we're dealing with big things, you know, big parts. And the ductance, you know, power stuff, you know, it's big. Bigger wires, longer leads. So, yeah, not good for higher frequency. But, again, audio frequencies, it's easier to get around that. Okay, so, and plus, it's not changing very much, right? Okay, so guys, let's jump from this 4 ohm right down here. All right, guys, so what I'm going to do is I'm actually going to save this 4 ohm curve. Okay, I'm going to delete the 1 ohms. I'm going to save this one, and we'll compare it to this 4 ohm and this 8 ohm. Okay? All right, so let's save this guy. So we got it saved, okay? So that's 4 ohm. I'm going to call it 4 ohm, and it's the middle resistor. So that'll help us remember which one's which. Okay, so now let's go to, now it's higher in resistance, so, you know, that would mean like the inductive components won't have as big an impact, you know, in relative to the resistance, right? Okay, so let's see what it does. Okay, I've got to take, okay, well, I'm up to 300, so we're going to get the resistance is way down here. Let's see how high it goes, and then I'll, yeah. So it's actually going a little higher, because I guess it's, well, you know what? It's probably going to have more inductance because it takes more turns and stuff to make the 8 ohms. Yeah, so there you go. That's why we measure, so we know, right? Okay, let me go ahead and save that guy. Alright, so I've got those 2 pictures saved. And the phase, by the way, phases come across here at 0. It starts to change, you know. It'll change like 45 degrees at half at the 3 dB point. So that's kind of the thing. So it starts to change early because it's got to get up there at the 3 dB point. So right up here at 45, that's not even the 3 dB. Well, maybe if you're in decibels, but yeah, that'd be around 100K. So yeah, it's still way out there, right? Alright guys, so now let's go to this big green guy. I'm going to have to spread these guys out so I can reach across the terminals. Okay, there we go. Yikes. Ah, just barely making it. Alright, wow, look at that. So when you look at the phase, you can tell it's not changing. I mean, it's 45 degree thing is way out here at 6 or 7 megs. So, man, that looks better, right? Okay, I'm going to save that too. So I save the same picture. Now what I want to do is zoom down into these. I'm just going to go 10 ohms. We're going to zoom down on these resistances. So here's the 8 ohm, the orange one, right? It's kind of hard to see, I know. Let me go here and make that weight of that line heavier. Okay, there's the orange ones. That's the 8 ohm. And I think the other colors are probably okay. So, well, I'll make the green since it's kind of hidden. I'll make that a little bit bigger too. So there's the green ones. And you know what? For now, I'll turn off the phase so it's easier to picture to see just the ohms. So there you go. So 8 ohms out here, the middle one. So if we go 10, 20K, it's going to be about 8.5 ohms. It started off just above 8 ohms, like 8.1. So really it changed about 0.4 ohms to get to 20K. And then it takes off. And then the 4 ohm, same kind of thing. It's 4.1 maybe. It goes 4.5. Well, it goes to a little higher, 4.6 at 20K. So, and then it takes off. Boy. So guys, this green one here, this is impressive. I thought for sure this would be more inductive, but man, look at this. This is great. It goes way out here to around 100K before you even start seeing it move up. So I got me another one of these green ones so when I can do the 4 ohm measurements. Hey guys, I'm going to put links down in my tab, so if you guys want to buy some of these resistors, I appreciate it. You know, I'm an affiliate at Amazon and eBay as well, and so I get a little bit of a very small percentage these days. They don't do what they used to do. And man, eBay's seems like they're even worse. But hey, every little bit helps. That's the thing, So yeah, use the links. Appreciate it. So that resistor is impressive. Man, that's great. So here we are, guys. Big old parts like this, resistors with lots of wires wound around, a piece of ceramic to make some resistance. And we still have ways of making them non-inductive in a very simple way. It's just one of those things that has been done for a long time. The audio band, especially out to 10K, there's like no changes, like insignificant changes. Like, 20K, you could even call that insignificant. It's barely changing, and that's beyond even young people's hearing, by the way. Some people, there's a small percentage people can hear out that far. We like to all think we could one day, when we were younger, that we were invincible and we could do everything. But 16K, 18K is probably more realistic. But just physics, guys. The setup, I'm just showing I'm going to start using these, but even the metal ones, they behave really well at 10K. Now, when I do my sweeps out to 100K, maybe these resistors were impacting my measurements. So, that might be possible. Now, if I use this resistor, it looks like I can go out to 100K, and I'm okay. I'm okay to use this. Anyway, what do you think? It's great to take measurements of each part of your system. Oh, kind of like how we buy our audio system. Okay, guys, thanks for watching. 2 big thumbs up to my patrons and my YouTube channel members for supporting me. Really helps a lot. I went out and bought a bunch more connectors and a bunch of things, so really appreciate that, guys, because yeah, I need to start selling some of my older equipment too, right? But anyways, all right, guys, thanks for watching. We'll see you next time.